Mirror Reflections, home of the damn Yankee Workshop. So we figured today we would do a video on axial constant positioning of the grinding wheel on our Weinig R960 grinder. So let's just jump right into it. We'll figure out, this is our Weinig R960. We're going to give you some dimensions and do some adjustments on a fresh grinding wheel and a fresh bores-on wheel. Show you how to align it. First of all, we're going to use the word axial constant a lot. If you own a Weinig, you probably know what axial constant is. If you don't, axial constant, it sounds like a complicated word, but it's really nothing more than a constant position of the axial setting on your molding knives. And in order to obtain this, you have to have your grinder speaking, quote, axial constant, and your molder, quote, speaking axial constant. And you can find different articles we wrote on our website, www.mr-moldingknives.com, and it'll give you a breakdown. This will also give you a breakdown of this video, step by step. You can print it off and follow the steps, or watch the video and just stop it and as you proceed. So first of all, we'd like to show you our grinder is a little different. This is a custom grinder. Most of you probably have the different type of grinder, but this one here, our grinder is the cradle to hold the arbor. This little spot here is the axial constant stop pin. These are the clamps that hold the arbor. We'll go through that. This here is our radial and axial adjustment of the diamond dresser. Here's our axial movement here. If you watch this dial, you'll see as we turn this, the dial moves, the dial indicator. This dial indicator is important. It lets you know where your setting is in relationship to the wheel. This is our radial adjustment. This doesn't have any kind of measuring device on it because it's adjust your template to the tracing pin. This is a tracing pin. These are the kip handle template holders. And this is our grinding wheel assembly. We have hydraulic clamping on our grinding wheel. And what that means is our grinding wheel is locked on hydraulically. And if you have this, you know what it is. So by releasing this pin, we release the inside of that. So that's what the grinding wheel looks like. I like to keep this area very clean, so we tend to clean it pretty regularly. It makes for the wheel to go on and off a lot simpler. Also clean the inside of the bore of the wheel as well. Okay? Now we're just going to put a little X on it because I'm going to show you with a new wheel. This wheel is halfway used, but I want to demonstrate with a new wheel. So I'm putting an X on so I know how to put it back next time when I take it off. We're going to stop with a rough grinding wheel. This is our GW 3500 ceramic blend wheel. The blue that you see is ceramic. The pink that you see is vitrified aluminum oxide. We tend to stick a shim between the flange and the wheel and the wheel and the flange. This shim keeps the wheel from sticking to the hub. So we change this on a pretty regular basis. So it's not an issue for us, but it just makes for a cleaner assembly when you put it together. It makes it come apart easier too. Sometimes if that wheel sits in there a long time, it sometimes sticks to the flange and it makes it a little bit difficult. So by using a shim, it makes it a little bit easier. We're not tightening these bolts fully tight yet. We're just going to... Okay, our wheel comes through at about 5 millimeters. We want to dress our wheel to 4 millimeters exactly. We have a couple of tracing pins here. This is a 2 millimeter tracing pin. This is our finished wheel. It's a 3. We don't use a 3. This is our 4mm tracing pin. This is our 4mm tracing pin round, 4mm tracing pin square. We don't use the pointed side. When we do use the square side, we use this when we're grinding carbide. The carbide wheel tends to go square over time, and we don't want to remove any extra carbide and have to grind down deeper when we go to the finish wheel. So we grind square because the wheel would be square. We just kind of slide this wheel on, push it all the way, pull it all the way to you, then push it all the way back. And take your, this is the hydraulic activation screw. As soon as I push this in, it puts pressure on the hydraulic sleeve and holds this grinding wheel to the auger. Okay, this is a diamond dresser. This is the old style winding diamond dresser. They have a new style out now, but this unit basically is the same. So we're going to put this in position. It locks into position. You can lock it here if you want. I don't use it. I just set it down there. This is allows us to move the diamond dresser and to move it side to side. If you notice, the 0 and 0 line up. These lines here, you see the 0 on this is lined up with the 0 on that. And then there's two lines. There's a center line and one line to the right and two lines to the right. That means that this wheel should be dressed at 4mm. Each line to the right signifies 2mm of wheel. Okay? So if we bring down the diamond dresser, we notice that it's touching because it's at the finished stop point. And when we stop, it's going to be based off where we're at. We're not touching now. So as you can see, the line's opened up. This wheel's about 5mm as it comes through rubber. There's two types of diamond dressers. This is a single point. This is used for vitrified wheels. And then we have a multi-point. There's a lot of little tiny chips of diamond inside there. This is meant for ceramic wheels. Because we use a ceramic blend wheel, we have both vitrified aluminum oxide and ceramic inside that wheel. So we tend to use the single point or the multi-point diamond. This time we've got a single point in there. I would suggest the multi-point if you're using an all ceramic wheel, and I would suggest the single point if you're using an all aluminum oxide wheel. We're going to dress this wheel now, and I like to cover my equipment. As you can see, this machine's about 5 years old and it's in excellent shape. And the only reason why it's in excellent shape is because I take excellent care of it. So I like to dress this area up here first. And I put a vacuum on when I'm dressing this, and so it'll be a little bit noisy. Just bear with me until I get it to the size I want. Now, I'm going to adjust the diamond dresser for you so you can see when we're done how to use this thing. Now this thing, when you're done, should be at 0 and 0 and two lines to the right showing. That'd be 4mm wheel. I always undersize the wheel to make it like 3.85, 3.8, 3.9, somewhere in that range. So when I go to my Borazon wheel, that I have a little extra steel on the molding knives, extra for the Borazon wheel to touch on. So you don't have to be 100% accurate on the alignment of the Borazon wheel. We'll get into that in the future. This wheel right now is 5.27mm. Okay, so it's going to get a little noisy in here for a second, and we'll go from there. Always use your safety equipment. Keep yourself safe. Spin your wheel, make sure nothing's touching. And you want to dress your wheel at about 2,000 RPM. So we're just barely touching. I roll over the edges.
advance your wheel. Taking about a 1/2 millimeter. About 5/10 every time. Now see, I'm reaching the 04 number. I'm getting close. Okay, I'm actually at 02. So, I'm almost at 0. I'm almost at 0 because I have this set so it's smaller than 4.0. As you can see, I'm just about at the 0 and at the 0 in 2 lines showing. Okay? So we want to take a measurement here. This indicator is not an exact science. As the diamond dresser wears, this gets out of calibration. So you want to concentrate on getting it. You see, I'm at 406, 409. Okay, I want it right at 4 millimeters to do the axial constant alignment. Once I'm done aligning the axial constant, I'll make it smaller. So it's smaller than when I change wheels. I leave a little bit of extra steel in the knives before. So let me just take this down a fraction more. We'll get it at 4 millimeters exactly. 4 millimeters. Okay. So here's the theory, okay? When you're at 4 and 0, now you're at 4 millimeters. The same size as your tracing pin. 4 millimeters. So now the wheel and tracing pin are identical. We're going to shave down this wheel when we're done aligning the axial constant, but for now we're going to make it exactly 4 millimeters. Now, I'm a little bit of a fanatic on keeping things clean, so I like to make sure that after I'm done dressing the wheel, that I take and clean everything, all the dust, so everything works fine the next time I want to use it. Okay, so let me get this out of the way. Look at all the mess you would have had on your grinder had you let that stuff fly all over the place. So keep your shop clean. You know what they say? Clean shop is a happy shop, and a happy shop are we. We'll get back into the alignment of this grinding wheel. Now, look at these pins on the template carrier. On the template carrier, these pins from here to here is a little fine adjustment underneath here for a bolt. If you need to adjust it, it'll turn. You want 200, on this particular grinder, 260 millimeters. Okay? So, over here we have different grinding arbors. We have for HSK at 3 5/16 diameter. We have 1.5 bore for most of the 4 and 13, and then we have an 1 and 13 arbor. We don't have any clients with 2 1/8 arbors. Okay? So, when this Weinig, the inventor of axial constant, basically, they use a 10 millimeter axial constant. And that 10 millimeter is reflected in their grinders as well as their molders. And again, refer to the articles. When I put the spindle nut on the end of the arbor and tighten it hand tight, we have now 240 millimeters of arbor on all of these. When I close them down, 240 millimeters, 240 millimeters. Now, we have 260 millimeters on the template carrier. So, 260 millimeters on the template carrier minus 240 millimeters on the arbor leaves you 20 millimeters left over. That 20 millimeters is left for 10 millimeters axial constant right, 10 millimeters axial constant left or bottom, right or top cut heads, okay? So when we make our templates, we have lines here from the edge here. It's 20 millimeters from the edge of the template to the start of the profile. But when we cut the steel only 3/8 or 10 millimeters from the edge here to the start of the profile. Remember at the beginning I said axial constant was just a constant position of all your axial. So every knife we make starts, the knife will be here. If you look at this template, the knife is 10 millimeters extra and short here as well. The knife profile always starts 10 millimeters in. The template is 20 millimeters, so you don't fall off your knife and the template at the same time. You fall off your knife at the 10 millimeter mark, and you still have another 10 millimeters of resting for your tracing pin on your template carrier. Now, in order to align this, we use the dial indicator, and we use this donut. This donut, from the inside to the outside diameter, is 10 millimeters. That 10 millimeters is important when we get to this template carrier. We stick the donut on the tracing pin. We take a template. We put a template in, lock it in place. We twist it. That's the 10 millimeters extra. We have 260 millimeters from pin to pin. We're taking up the 10 millimeter extra. So, in theory now, from edge of template to edge of template is 240 millimeters. This donut, and this what I'm doing here is just for alignment purposes. You do not use this when you're actually grinding a knife. When you grind a knife, you stick the template to the edge, and you stick the template to the edge here. In this case, I'm just using these templates so I got a tall edge so I can reference off of with a straight edge when I test this wheel, okay? So, on the arbor now, and the arbor and our templates are exactly the same.